All right, we're going to talk about one more way of solving a system of 2 by 2 equations. And before we talk about that, we have to talk about something called a determinant. And to look at determinants, we're going to recall the formula for an inverse of a 2 by 2. So here's what that looks like. If I have a matrix A and the entries are A, B, C, D, then the inverse of A is going to be 1 over AD minus BC. And then you switch A and D and you negate B and C. So if you look at this formula, for what values would this function not be defined, or not function, this expression right here not be defined? And you should recognize that when the denominator is equal to 0, this part's undefined, and that's when this will not have an inverse. So a square matrix does not have an inverse when AD minus BC is equal to 0. So this expression determines whether A has an inverse or not. So therefore we call this thing the determinant. So we're going to formally define the determinant. Given matrix A, and it's equal to A, B, C, D, so this is a determinant for a 2 by 2. The determinant, denoted by det of A, this is the calculator version. We denote it that way, or we actually denote it with these absolute value symbols. So you could say this also represents the determinant of A. Or sometimes we skip the name and we just do the absolute value symbols with the entries of the matrix. All three of these things are different ways to denote the determinant. So all of those, the determinant is this, AD minus BC. So it's kind of a crossways product, A times D minus B times C. That's the determinant. So we're going to work an example where we calculate the determinant. And here's our example. Given matrix A is 6, negative 3, 2, 3, so it's 2 by 2. I want to evaluate this. Now that does not stand for the absolute value of A. This is going to create a single number, and it's the determinant of A. So it's going to be what we end up with when we multiply 6 times 3 minus negative 3 times 2. So we'll do that. The determinant of A is equal to 6 times 3 minus negative 3 times 2. So this is 18 minus a negative 6, 18 plus 6, and that's going to be 24. What that tells us is matrix A has an inverse because the determinant is a number other than 0. So here's another way of saying it. If A is a square matrix, then A has an inverse if and only if the determinant of A is not equal to 0. So if you want to figure out if a 2 by 2 has an inverse or not, calculate the determinant. That'll tell you. Now, for determinants higher than 2 by 2, you're going to use your calculator. So let's do an example where we calculate the determinant of a 3 by 3. So here's our example. We want to find the determinant of C, given that C is a 3 by 3, 503, 218, 3, negative 20. Now there's not much I can show here. What you would do is you would enter the matrix in your calculator, and then you would go to the matrix button, and under the math menu, so matrix and then math, there is a DET with parentheses command. So you would call that up to the main screen and then enter C in there and press enter, and you're going to get an answer of 59. So if you have a graphing calculator, try that out. Enter this matrix in there, and then go back and call up the determinant function, and then put the C in there, and hit enter, and you should get a value of 59. All right, another use of determinants is something called Cramer's rule. And Cramer was a mathematician, and he figured out that determinants can also be used to solve systems of linear equations. So I'm going to give you Cramer's rule here, and we'll work through an example and then look at more of this in class. So if I have a system, ax plus by equals r, cx plus dy equals s. X and y are the variables, a, b, c, d are the coefficients, r and s are the answers. This is what the solution would look like to this system. My x value is going to be the determinant of this matrix, r, b, s, d, all over the determinant of the coefficient matrix, a, b, c, d. So take a look at this. R and S are my answers. They've replaced the x coefficients. So the x solution is the determinant of the matrix where the answers replace the x coefficients and the y coefficients are there, divided by the regular coefficient matrix. That will give me my x answers. And y has the same pattern. It's going to be the determinant of the matrix when you replace the y coefficients with the answers all over the regular coefficient matrix. So there's a lot of letters to soak in, but this is the gist of Cramer's rule. Now that's provided that the matrix has an inverse. So that's provided that the determinant of the coefficient matrix is not equal to 0. If it is, then we can't solve it. So we're going to work through a numerical example here, and then we'll do some more in class. Alright, here's my system of equations. I have 2x plus 6y is -1, and x plus 8y is 2. And we're going to use Cramer's rule to solve this system. Now granted, you could use addition, you could use substitution, you could graph it. There's a lot of ways to solve this. I'm just showing you one more way. So this is how you use Cramer's rule. My x answers. X is going to be equal to the determinant. You replace the x coefficients with the answers. So -1, 6, 2, 8. And divide that by the determinant of 2, 6, 1, 8. That's going to be my x value. My y is going to be 2, -1, 1, 2 over 2, 6, 1, 8. Again, I take the answers, and for the x I replace the x coefficients. For the y I replace the y coefficients. Now all we do is process the determinant. 1, 2, this one, and this one. So for x, the numerator is going to be -1 times 8 minus 6 times 2. So -1 times 8 minus 6 times 2. There's my numerator. The denominator is going to be 2 times 8 minus 6 times 1. Now both x and y will have the same denominator. So y is going to be 2 times 2 minus -1 times 1 over the same as x, 2 times 8 minus 6 times 1. So this reduces down to -8 minus 12, and that's going to be -20 over 16 minus 6, so that's -20 over 10. So it looks like x is going to be -2. Okay, for y, we're going to have 4 minus a -1, so 4 plus 1 is going to be 5, and that again is over 10. So my y value is going to be 1/2. In this case, the solution using Cramer's rule is -2, 1/2. If you were to solve this any other way, if you were to solve it using addition, or graphing or anything, you're going to get the same answer. So you can always check your work too when you substitute it back in. If I put in -2 for x and 1/2 for y, I get -4 plus 3 is -1, and -2 plus 4 is 2. So the solution checks. We'll be working more of these in class so you can get the hang of how to use Cramer's rule and the determinant to solve a system of equations.